Have you ever wondered how search engines actually work? How can big tech companies instantly find a user? Do they just rank something like? Obviously not. Search at scale is far more complex than a simple database query. These companies handle millions, sometimes billions of users. Now imagine all those users search for friends, old photos, messages, posts. A naive approach will take an enormous amount of time to process each request, not to mention the massive infrastructure costs required to scale both horizontally and vertically. To deliver fast response and keep the system smooth and reliable, we need a much more efficient strategy. This strategy has a name: inverted index. Every time you search for a friend on your favorite social media, Instagram, TikTok, or even when you type something into Google, an inverted index is working behind the scenes. It's the backbone of modern search engines and one of the most powerful data structures for fast information retrieval. But before we dive into how it works under the hood, let's take a look at the naive approach. How it works. The naive approach is simple and straightforward. If you want to find a user by a name, we typically run a query. This works perfectly fine for small applications. However, it introduces a bottleneck as your dataset grows. To find a match, the database needs to scan every row in the table to check whether the search appears. If you have n documents, for each document, the system must read its content, check whether the search term exists. This results in a full table scan. Now imagine your system has 10,000 users or more, and this operation is executed frequently. Costs become significant, leading to slow performance and the necessary load on the database. Time complexity. Although this method uses minimal memory, it does not scale as the system grows. When it is acceptable, very small datasets, one-off scripts, prototypes, systems where search latency is not critical. What's in an invert index? Imagine you are searching for the word cat in a large stack of documents. With the naive approach, you would look at each document one by one and check whether the word appears inside it. An inverted index flips this logic. Instead of asking which documents contain the word cat, in other words, an inverted index maps each term to the list of documents where it occurs. This dramatically reduces search time. The system no longer has to scan every document. It simply looks up the word in the index and immediately retrieves all matched documents. This approach is a game changer for performance, especially in applications with large datasets, frequent search, or full text search features. Because now, when someone searches for cat, we can directly access the documents where the word cat appears. No scanning, no guessing.